Hey everyone, welcome to this video, and in this video we are going to learn about open circuit and short circuit of the digital electronics and the applied electronics concept. So let us start the video. A circuit is said to be open when any part of the path is open or broken, and there is no continuity in the conducting path Now what happens is that the open circuit may be in the connecting wires or in the load resistance. An open circuit gives rise to the following two effects. Number one, the resistance of the circuit is infinitely high. That is, the resistance of the open circuit is infinitely high. And the second point is, there is no current in the open circuit. Now let us understand this using a very simple diagram. So let us say we have a situation. Let me take the different pen. Okay, so let us say if we have a box like this over here, and this box basically represent rest of the circuit, and let us say this is terminal A and this is terminal B. So this is A and this is B, and this is open circuit, that is OC. So in this case, the value of resistance across the terminals would be infinite and the current across the terminals would be 0. Now this is the open circuit. Now let us in the same diagram see what is a short circuit all about. So let us say if I draw a box like this, and here I write this as rest of the circuit, and let me draw this as terminal A and this as terminal B. So when both of them are connected by a wire, this is the case of a short circuit or SC, and in this case the resistance across AB will be 0 and current across AB would be equal to the current of the short circuit. So this is a short circuit current. So let us write the definition below. A circuit is said to be short when the voltage source has a closed path across its terminals, the resistance is practically 0. So, the resistance in this case is practically 0. Now, usually the short circuit basically is a bypass across the load resistance, and a short circuit gives rise to two conditions. First, the resistance of a short circuit is 0. As a result of this, there is no voltage drop across the short circuited paths, and there is a large flow of current through the short circuit, and this is referred to as a short circuit current. So, even in this particular diagram here, you can see that we have drawn two circuits. So, this is the rest of the circuit, in which case two of the terminals are open over here, and that is why these will be referred to as an open circuit. Now, in the open circuit, what happens is the current across the terminal is taken as 0 and the resistance across the terminals is taken as infinite. The same case is observed in case of the short circuit. In short circuit, what happens is that you join the two terminals by a wire. So what that does is that it provides the current to flow in an alternate path in which the resistance across the terminals would be treated as 0, and the current across the terminals AB would then be equal to the short circuit current. So the short circuit current is basically the current when that kind of flows in the circuit when the two terminals are joined hand to hand in such a place where these kind of positions result in something which is known as a least resistance path. So what the current will do is when like it will follow in a short circuit condition, it will get an alternate path where the resistance is practically 0. Hence, instead of flowing in one direction, it will start to flow in this part of the wire where it will get the resistance as 0. But that is not the case with the open circuit, because an open circuit is said to be open when any part of the path is open or broken and there is no continuity in the conducting path. The open circuit may be in connecting wires or in the load resistance, and an open circuit gives rise to the following two effects. First, the resistance of the circuit is infinitely high, and the second is that there is no current in the open circuit path. And what about the short circuit? So a circuit is said to be short when the voltage source has a closed path across its terminals and the resistance is practically 0. So with this kind of we wind up the video for the day. I hope that this video was informative enough, and for more such videos, don't forget to subscribe to our YouTube channel. Thank you so much for watching, and we will meet soon. Please subscribe to our channel and share this video with your friends. Goodbye.